All right, class, in this lesson, you are going to learn to solve radical equations. So let's go ahead and get started with example 1. So here we're going to solve an equation with one radical. We have the radical square root of x plus 5 minus 1 is equal to 3. Okay, so the way to solve this is to first move the negative 1 to the other side of the equation. And so when we do, we get square root of x plus 5 is equal to 4. Okay. Then the next thing we're going to do is square both sides. So we're going to take that squared and we're going to square 4. And when we do, we are left with x plus 5 is equal to 16. Okay. Then we're going to subtract 5 from both sides and we get x is equal to 11. Okay, so one of the things that we want to do whenever we are solving equations with radicals is to always put the answer back into the original equation just to make sure that it makes sense. Okay, so let's just do our check here. Our check. So does the square root of 11 plus 5 minus 1 equal to 3? Well, square root of 11 plus 5 is the square root of 16 minus 1. Does that equal to 3? Square root of 16 is 4 minus 1 equals 3. And 4 minus 1 is 3, and that is equal to 3. So that checks out. All right, so let's move on to another example. Here we're going to solve the radical equation cube root of x plus 2 is equal to 4. And what we're going to do is move this 2 to the other side by subtracting 2 from both sides. And when we do, we get the cube root of x is equal to 2. Then what we're going to do is cube both sides. And the result is x is equal to 8. Okay, so let's go ahead and do our check again. And ask ourselves the question, is the cube root of 8 plus 2 equal to 4? Well, the cube root of 8 is 2 plus 2. Does that equal 4? And yes, 4 does equal 4. Okay, so that definitely checks out. Okay, so now let's move on to another example. This is where we're going to identify an extraneous solution, and I'll show you what I mean by this in a minute. So here we have the radical equation square root of 3x minus 2, and that is equal to x minus 4. Okay, so what we're going to do here is we are going to square both sides. So we're going to square this, and we're going to square that. And when we do, on the left side, we get 3x minus 2. It takes care of the radical. And on the right side, this becomes x minus 4 times x minus 4. And so we're going to have to multiply that out. And we get 3x minus 2 is equal to x squared minus 8x plus 16. Okay, so now what we're going to do is move both the 3x and the negative 2 over to the other side of the equation. So let's do this one step at a time, just to make sure that you understand how the movements are taking place. So we're going to subtract 3x on both sides. And when we do, we're left with negative 2, and that's equal to x squared minus 11x plus 16. And then we're going to add 2 to both sides. And when we do, we're left with 0 is equal to x squared minus 11x plus 18. Okay, now we're going to factor this. And this factors out to x minus 9 and x minus 2. Okay, so using the zero product property, we find that x is equal to 9 or x is equal to 2. Okay, so now we're going to have to check this, okay? So I'm going to go to the left side here. Let's do our check. I'll do this in a different color. So, is the square root of 3 times 9 minus 2, does that equal to 9 minus 4? Okay, so that was the original equation. So let's go ahead and work this out. 3 times 9 is 27. Minus 2 is 25, and does that equal to 5? Square root of 25 is 5, and that is equal to 5. So that checks out, okay? But let's take a look at another check where x is equal to 2. So let's say we've got 3 times 2 minus 2, and does that equal to 2 minus 4? Okay, so now under the square root sign, we're going to have 6 minus 2 is equal to negative 2. Square root of 4 is equal to negative 2. And we see that the square root of 4, which is 2, does not equal negative 2. Okay, so this does not check out. So that means that x equals 9 is our answer. Okay, and this x equals 2 is our extraneous solution. Okay, and it's extraneous because of our check here. We see that this doesn't work out. Okay, so let's go ahead and move on to example 3. Now we're going to solve equations with rational exponents. Here we have x squared plus 5x plus 5 raised to the 5 half power, and that is set equal to 1. Okay, so what are we going to do here? First thing we're going to do is take x squared plus 5x plus 5, and that's raised to the 5 halves power, and we're going to raise this whole thing to the 2/5 power, and we're going to do the same thing to the other side, also raised to the 2/5 power. Okay, and when we do, this comes out to x squared plus 5x plus 5 is equal to 1. Okay, so now we're going to subtract 1 from both sides, and we get x squared plus 5x, 5x plus 4 is equal to 0. Okay, and we're going to factor this, and we're going to set it equal to 0, and we find that x plus 4 and x plus 1 are our factors, and using the zero product property, we find that x is equal to negative 4 or x is equal to negative 1. Okay, so now what we need to do is plug each of the x values into the original equation and check to make sure that they work. Okay, so let's go ahead and do that. We're going to do our check here on the left side. So we're going to use the x equals negative 4 value for our first check, and the question here is negative 4 squared plus 5 times negative 4 plus 5 all raised to the 5 halves power, is that equal to 1? Okay, well, let's go ahead and work this out. On the inside, we've got 16 minus 20 plus 5 raised to the 5 halves power, and is that equal to 1? 16 minus 20 is negative 4 plus 5 is equal to 1. 1 raised to the 5 halves power, is that equal to 1? Well, 1 raised to the 5 halves power is 1, so 1 does equal 1. So that checks out. Now let's check out the other value. I'm going to do this on the right side. And the question here is negative negative 1 squared plus 5 times negative 1 plus 5, all raised to the 5/2 power. Does that equal to 1? Okay, well, let's go ahead and work that out. That's going to be 1. Negative 1 squared is 1 minus 5. 5 times negative 1 is negative 5 plus 5 raised to the 5/2 power. Does that equal to 1? 1 minus 5 is negative 4. Negative 4 plus 5 is 1. So we have 1 raised to the 5/2 power. Does that equal to 1? And yes, 1 to the 5/2 power is equal to 1. And so therefore that checks out. And so these, negative 4 and negative 1, are both our answers. Okay? All right, let's take a look at part B, or second example, which is x plus 18 raised to the 3/2 power is equal to x minus 2 cubed. Okay, so what do we do here? We're going to take this equation, and what we're going to do is raise it to the 2/3 power. Now, why do we raise it to the 2/3 power? Because we have this raised to the 3/2 power, and so we want to raise it to the reciprocal power, and by doing that, these end up canceling out. Okay. Now, when we do that, when we raise it to the 2/3 power, we have to do that to both sides. So we're going to raise this to the 2/3 power. And when we do, we get x plus 18 is equal to x minus 2 quantity squared. Okay. Just as a reminder, when you raise a power to another power, you're going to multiply them out. So 3 times 2/3 is just 2. Okay, and that's why we have this 2 here. Okay, so now we've got x plus 18, and we have this quantity squared. So let's go ahead and write this out. This is really the same as x minus 2 times x minus 2. And when we multiply the two binomials, we're going to get x squared minus 4x plus 4. And then what we're going to do is move both the x and the 18 to this side. And when we do, we get 0 is equal to x squared minus 5x minus 14. Okay, now we're going to factor this. 0 is equal to, and this factors out to minus 7 plus 2. And using the zero product property, we find that x is equal to 7, or x is equal to negative 2. Okay, now we're going to have to check this out. We're going to go ahead and start with x equals 7 and put that back into the equation here, into the original equation. So here we've got 7 plus 18 raised to the 3/2 power, and is that equal to 7 minus 2 cubed? Okay, 7 plus 18 is 25 raised to the 3/2 power is equal to, is that equal to 5 cubed? Okay, 25 raised to the 3/2 power is the same as the square root of 25 raised to the 3rd power. And is that equal to 5 to the 3rd? Square root of 25 is 5. 5 cubed is equal to 5 cubed. So that checks out. And let's do one more check on the right side here. I forgot to write the word check on the other side, but hopefully you understood that. Is negative 2 plus 18 raised to the 3/2 power equal to negative 2 minus 2 cubed? Well, negative 2 plus 18 is 16 raised to the 3/2 power, and is that equal to negative 4 cubed? Okay. 16 raised to the 3/2 power is really the square root of 16 cubed. And is that equal to negative 4 raised to the 3rd power? Well, square root of 16 is 4 cubed, and this does not equal to negative 4 to the 3rd power. Okay, so that does not check out. So our solution is going to only be x equal 7. Okay, let's move on to example number 4, and this will be our last one for this lesson. Here we're going to solve an equation with 2 radicals. Okay, so when we have 2 radicals, what we're going to do is move the second one to the other side of the equation. And when we do, we get square root of x plus 9 is equal to square root of 2x plus 3. Okay, now we're going to square both sides. It's going to be squared, and when we do, on the left side we just get x plus 9, and on the right side we're going to get square root of 2x plus 3 times the square root of 2x plus 3. Okay, and when we multiply that out, we're going to get 2x, okay, plus 6 square root of 2x plus 9. Okay, and then what we're going to do is subtract x from both sides. And when we do, we get 9 is equal to 6 square root of 2x plus 9. We have 9 on both sides of the equation, so we can knock that out. And now we have 0 is equal to 6 square root of 2x I believe I made a mistake here. Yes, I did. And the mistake here was 2x minus x should not have disappeared. So I'm going to go ahead and reinsert that. Oops. Let's do that again. Here we're going to get x plus 6 square root of 2x. Okay, the 9 still cancel out, but I need to put the x back in here. X plus 6 square root of 2x. Now we're going to move x to the other side of the equation, and when we do, we get negative x is equal to 6 square root of 2x. Okay, so now what we're going to do is square both sides, and when we do, we get x squared is equal to 36 times 2x, and that works out to x squared is equal to 72x. Now we're going to move the 72x to the other side of the equation, and we're going to get x squared minus 72x is equal to 0. Now we're going to factor out the x, and we get x minus 72. That is equal to 0. And so our solution is using the zero product property, tells us that x is equal to 0 or x is equal to 72. Okay, now as usual, we're going to have to check this out. Okay, so let's go ahead and go back to the original equation, which is here, and let's do our first check. Okay, so we're going to check on our answer being 0. So the question is square root of 0 plus 9 minus the square root of 2 times 0 equal to 3. Okay, well, this comes out to square root of 9. That comes out to 0. And does that equal to 3? Square root of 9 is 3. So 3 is equal to 3. So that checks out. Okay, now let's do our second check. our second check is going to be for when x is equal to 72. So the question here is 72 plus 9 minus the square root of 2 times 9, does that equal 3? Okay, 72 plus 9 is 81, minus the square root of 18, does that equal 3? Sorry, not 9. This here is not 9, it should be 72. My apologies. So 2 times 72 works out to be 144. Okay, now square root of 81 is going to be 9. Square root of 144 is 12. And does that equal to 3? The answer is no, because 9 minus 12 does not equal to 3. Okay, so what that means is our solution is x equals 0 only. Okay, hopefully that made sense, and I apologize for the minor errors that I made, but hopefully you were able to follow the steps that I provided. If any of this was confusing, please go back to the beginning of the recording and listen to this again. Thank you.